Jai Hind. I Rupak Kumar from IT department. Today's we are going to know about the normalization topic from database management system. So in database management system, we can have a data which is saved or stored and make a database for different purpose. So that data must be normalized. So for designing a database, we must have a normalized data. So first we come to know that how we start the normalization. So for study the normalization, first we come to know what is functional dependency. This is a related topic of normalizations. So what is functional dependency? So first, if we have suppose we have a relation R schema having attributes A1, A2, A3, AN, means like that. Here the student table is given. In this table we have roll number, name, marks and grade, and these roll number, name, marks and grade have a relations with a student, means students tables gives some relations like student name, marks and grade. This is what the attributes from a student table. Now how these attributes is functionally related? So we can take an example like the grade is functionally depends on marks, means marks determines the grade. So this is what we can say. Let there is an attribute X and Y like grade are two subset attributes of a relation R, means in this table we have a relation student. So if the value of X components of a tuple uniquely or functionally determines the value of Y components, then there is a functionally dependency from X to Y. Means we can say the mark grade is depends on marks only. If there be any change in marks, we just find the change in grade also. Means grade is determined with the help of marks only. So this is what we can say the fully functionally dependency. Okay. So we can say that marks arrow grade. This is what how we show the dependency of attributes. X gives Y, means Y is depend on X. So it is referred as Y is functionally dependent on X only in this case. And another word we can say X functionally determines Y, means if we have X then only we have Y, then we can find the Y, that is what grade. If we have marks then only we can find the grade. Clear? Next, with the help of diagram we can just find the functional dependency, some examples of functional dependency. So consider the relations, like suppose we have a relations like X gives Y, means we can determine Y only from X only. In second scenario we have a second types of dependency, that is what Y is depend on X1 and X2. This is what the dependency of another type, that is X1 and X2 combinedly determines Y. Clear? And it is written as X1 X2 in a curly braces gives Y. Next we have X gives Y1 and X may gives Y2 also. This is also some other types of functional dependency, that in this scenario we can have Y1 and Y2 is functionally determined with X value only. So this is some examples. So we can consider the relations like account number, balance and branch. So these we can say if we have account number then easily we can find the balance and branch. So with the help of example we can understand how these attributes of database it functionally depends on another attributes. Means here we can see balance and branch can be determined with the help of account number only. Means account number can determine the balance and branch both Another scenario we can say, we can find the functionally dependent, means we can say there is a functionally dependency from account number to what? To balance and branch. So this can be denoted or written as like this. That is what? Account number gives balance and branch. Clear? Now if we talk about the types of functional dependency, so we can say we have, if there is some relation, that is what? X and Y, that are attribute set of relations, and Y is fully functionally depends on X. Then we can say if Y is functionally determined depend on X but not on any proper subset of X. We can take an example like that. If there is some dependency on like A, B, C determine D, so we can say there is no any subset. If we find the subset of these A, B, C, we can have the subset like AB, AC, or we can say CA or AC, AC, AB, AC and BC. Okay, so these three are the subset. We can have A also, B also and C also. So these are the subset of ABC, but we can say if it is fully functionally depends, it means D is fully functionally depends on ABC, then we can say there is no any other subset like AB cannot determine D, AC cannot determine D, BC cannot determine D, means alone it is not determine the D. Clear? So we can say that these D is fully functionally depends on ABC. So this is what in the relation ABC determine D attribute and D is fully functionally dependence on ABC and are not any proper subset, means these are the proper subset of ABC. So no any proper subset that that means that the subset of ABC like AB, BC, A, B, etc. cannot determine D. Clear? So we can say this is what the fully functionally dependency. Clear? And there must be some partial dependency also, means if AC determined B and AD determined D, then we can say D can be, then we can and there is a D determined B, then we can say now if we can compute the closures of A plus, means what is the closure? Closure is that basically if we find the closure of anything, first of all we can write the A is the closure of A, then what we can find from A? We can find the D, we can find D, and from D we can find B. This is what the functionally dependent, that's why we can find these. Or if we have a ABS, this is what the ADB. So now we can say this is what closures of A is this, hence A is alone capable to determine B. Means in this scenario we can say if this is what the closure means, that is A can be determined any subset of this, means A can determine A can determine D, A can determine B. So this is what we can say functionally dependency of other data. Clear? Now next type of dependency, that is what the transitive functional dependency. So in a relation, if attributes A gives B, B gives C and A gives C, means C is transitively depends on A, means A is not directly gives C, but A gives B and B gives C. So we can say that A can also give C. This is what they are depends on other, but they can directly determine these value. So this is what we can say transitive dependency. Like if a subject, a faculty, subject determines some faculty and faculty's age is given, age is determined by some faculty, and we can say with the help of this subject we can find the age of that faculty. So this is what we can say transitive dependencies, example of transitive dependency. So therefore, as per the rules of transitive dependency, subject age should holds that mark. That makes the sense that because if we know the subject name, then we can know the faculty age, because we know the subject, which subject is assigned to a faculty, and we can know these subject is assigned to faculty and faculty age is there, then we can find the age with the help of subject, because they are transitively depends on each other. So therefore, this is what the example here given, subject, faculty and age, and if we have a name of the subject, we can say the age of this faculty is 35. So this is what transitive depends. This gives faculty names and this is given by this. So this can be determined with the help of this. Clear? Now next type of dependency is trivial dependency. Trivial functional dependency means if y is determined with x, means x gives y, is a trivial functional dependency. If y is subset of x, means if we can take an example, if we have a roll number, department name and semester, then we can say we can find these all can be found with the help of roll number. If we have roll number, we can find the department name, we can find the semester of the student. Next, we can have a non-trivial functional dependency. If we have x, y depends on x is a non-trivial functional dependency, means we can say y is not a subset of x. So we can take an example like this: roll number, department name and semester. This is what we can say. A student name can be find with the help of roll number, because roll number is a primary key, so it can be determined. So student name can be find with the help of these dependencies. Clear? So these are the fundamental things which we need to find the normalizations of a table. This is what one of the important topic of database management system, normalization, or we can say in general it's normal forms. So what is normal form? Basically, if we talk about the normal form, we can say it is the process of removing the redundancy of data from tables. So what we do with removing this redundancy means we do not have to write or repeat the data several times. So if we are not repeated the data, that means we are going to save our memory. So in terms of if we talk about the computer, then we must have always try to save our time and space. That is what the memory. So if the data is written several times, it must take some more space in your computer. So we just try to restrict the repetitions of data from the tables. So we can say it is the process of removing the redundant data from the tables to improve data integrity, improve data scalability, improve storage efficiency. These are the important keywords regarding this, that we are just going to save our storage efficiency, we can have a scalability of data, we can have a integrity of data. So if we talk about the integrity means completeness, accuracy. Data must be complete, data must be consistent, consistency of data, accuracy of data or completeness of data. That is what the integrity of data, and this is what determined only when we have a normalized form of the data. Clear? Next point is that what is scalability? Scalability means that ability of a system to continue to a function well in growing amount of work. This is what the scalability of the data. Next we have a storage efficiency. What is storage efficiency? So it is what the ability to store and manage the data. It is what to consume the least amount of space from your computer. We are always concerned with the space, concerned with the memory in a table. So this is what we can do only when we have a normalized form of data. So what we do in a normalizations? First is that generally normalization is generally involves the splitting and existing tables. Actually, in a database, we have in RDBMS, Relational Database Management System, we have a data in the form of tables, rows and columns, and we just split that rows and columns to normalize the data. So with the help of these splitting, we can have a normalized data. So we can split these tables into multiple or more than one tables, so which can be rejoined or linked each time when a query is issued or executed. So we just split it, and when there is some query is fetching to access some valuable from inside, valuable from that data, then we can have a joint process also. So we rejoin or link that database so that we can find some valuable amount of information from that data. So this is what the importance of normalizations means. If we have a normalized data, so we can fetch the valuable query from that database. So database is very important, and we have a more important that we have a normalized data. So this is what the important things regarding the database. So normalization is basically to find a query very efficient manner, to save our space, to save our efficiency, storage efficiency. Next, we have some normal forms, types of normal form we can say. First, we have a first normal form. This is what the first normal form. If we have a table and data, we must have just decompose that data in first normal form. Second is that second normal form, third normal form. Then in fourth position we have a BCNF, that is bias code normal form. Next we have a fourth normal form and fifth normal form. So as we move from first to fifth normal form, means the number of tables and complexity increase, but we have a redundancy of data, means we just shorten the data, we just we just not write the data repeatedly. There we just save our memory more, but data must, the database is complex, but query is easy. We can find the any types of query from that database. So this is what the beauty of this normalization, that we can, as we move from the normal form from first to fifth, we can have a increase in complexity and decrease in redundancy. Now the first normal form. What is first normal form? So the first and only one conditions of the normal form that is that each cell of a table should contain a single value. Means every cell in a table in a database must be atomic value. So a relation R in the first normal form, we can say a relation is in a first normal form if and only if it does not contain any composite attribute or a multi-valued attributes or their combinations. So there must not be any multi-valued in the tables. So how we can secondly we can define, or we can define the relations in a first normal form. We can say if and only if all underlying domains contains atomic value, means all of are in a atomic form. There must not be two things in a particular cell. एक cell में we have only one item. This is what we can understand with the help of this table. In this table we can say there is a multi-value in a single cell. We have a customer table in which we have a customer ID, name and address. In this we can see this is the customer ID C1, CO1, CO2, CO3. This is what the name. Then we can have a address. Obviously address is in multiple, means we have a Jamnagar road in a Rajkot, Nehru road in a Jamnagar, CG road in a Ahmedabad. So this is what we can say in a first normal form. So in customer relation addresses is composite attribute which is further divided into sub attributes as a road and city. Clear? So we just do divide this. We just have a next road and cities like this. Here it is, we can see this. We can just divide this table as a this. Now it is now atomic value. There nothing is repeated in same cell. So this is how we can just take this table to a normal form. So now this table is in a first normal form. Clear? So divide and composite attribute in the number of sub attribute and insert the value in a proper sub attributes. So this is what we can say. This is what the first normal form. So in this way we just find the first normal form. Clear? So in next class we have the second, third and fourth normal form. We'll continue in the next class. Okay. Thank you all of you.